Good morning. This is our 17th lecture of AS and A-level chemistry lecture series. And in this lecture, we'll talk about inorganic chemistry. And what is inorganic chemistry? We know in periodic table there are 118 elements. More than 100 elements and their compounds are a branch of chemistry, which is inorganic chemistry. And because it is a huge number of elements and their compounds, therefore information are also huge. And to study this, we need to have a systematic way to study it. And the periodic table tells us how to study systematically. That is the essence of periodic table and justification of periodic table. Well, in AS level, the syllabus contain group 2, group 17, sulfur and nitrogen chemistry. Although we'll deal with carbon and related chemistry in organic chemistry when we started. But in inorganic chemistry is this, as I said, there are many elements, all grouped from 1 to 17 have elements, and their study will include inorganic chemistry, except carbon, silicon. Now, in AS level, we have only group 2 elements, group 17, sulfur and nitrogen, what I said. Here in the left, you see, I have taken only the group 1 and 2. So this is period 1, 2, 3, 4, 5, 6, 7. And if we go left, it is the groups. We include group 1 and this is group 2. One exception that what here is star marked, that hydrogen, though it is in this group, but the properties of hydrogen is rather different from these elements. So hydrogen chemistry is dealt, if we say that differently than that of this group and 1 chemistry. Okay, the trend in physical properties of elements have been discussed rather details, but there we didn't mention anything about chemistry of these elements. So we will talk about chemistry of these elements now. This 2, specifically 2 in this lecture, and comparing 1 with chemistry of 2, though group 1 is not included in syllabus of AS. So this is better that we compare these 2 groups. The element, first thing that we have this group 1 elements or group 2 elements in its compound show only +1 and +2 oxidation state. We discussed it in redox chemistry. It's only these 2. We will never see any variable oxidation state of these 2 groups of elements. This is very important to remember when we discuss chemistry of group 1 and group 2 elements. Well, group 1 and 2 elements are reducing agent. Why? Because it readily gives up their valence electron to form compounds. Here is the reaction how it gives up its electron for group 1 element and group 2 elements. And that also tells us that it will have only +1 and +2 oxidation state. Okay, I'm just showing you M as group 1 metals and M prime as group 2 metals. One thing is to be noted that M metals are relatively more powerful reducing agent than M prime. Next slide. Well, I've shown you here some metals of group 1 elements figures and some of group 2 elements. From left to right, it is lithium, it is then sodium and potassium. You might ask, why not rubidium and cesium? Well, rubidium, cesium in room temperature, almost in semi-liquid type, not like it is metal, though it is metal, but almost in semi-liquid type in room temperature. And group 2, you see, it's beryllium, magnesium, calcium, strontium, strontium, and barium. We can also talk about these two. Why didn't we talk about francium and radium? Because these are radioactive elements. So normally you don't get chemistry of these two in organic chemistry, rather you get it in nuclear chemistry. I can tell you one thing here, very simple, and you can remember that, though it is not in the slide, that what is chemical reaction? Chemical reaction, the rearrangement of valence electron. Now you can say, what is valence electron? So it is this, that is the valence electron of group 1 metal. What is N? N is the number of period, that's what I show. This is the valence electron. And this is the valence electron for group 2 elements. So rearrangement of this valence electron is chemical reaction. Do we have any other reaction? Yes, we do have. That is called nuclear reaction. What is that then? Rearrangement of nucleons in the reaction. And nucleons is proton, neutron. So if we rearrange proton and neutron, we get nuclear reaction. And in nuclear reactions, we can have more element which is not in reaction. New element we can get. But remember, for chemical reaction, you can never get new elements. You get only the same elements reacting and forming compound. Therefore, chemical reaction, energy of chemical reaction, much less than the energy of nuclear reaction. So we will talk now basically chemistry, that means chemical reaction, chemical compounds of these two elements. Well, here I have taken the comparison of ionic radii of group 1 and group 2. You see, if we go down the group, the ionic radii increases for both ionic radii. And it is truth that in all group, if we go down the group, the ionic radii increases. So, but if you compare this lithium ionic radii, you see the beryllium one is smaller than lithium, because beryllium is doubly charged. We have taken 2 electrons from here. Same thing happens here also, here also, here also, here also. So this is also one thing we should have noted for chemical reaction. Well, this is what I'll discuss about a flame test. In AS level or A level practical exam, you always get these to identify the salt given to you and tell what is in the salt. A flame test is done for detecting the metal ions in the samples. Well, here ionic compounds, this group of elements and this group of elements form ionic compounds. So in the flame, the heat energy we get, we never can burn down the ionic compound. Let's say sodium chloride, we cannot burn it down by a flame. But what you can do, the flame will give you an energy, and this energy will excite atoms in the metal ions and raise it to higher energy level. But it cannot be there in higher energy. It drops out when you take out the energy given by the, it drops out. And while it is dropping out, we get an emission, characteristic flame emission. And that flame emission, or color of that flame emission, tells us which element in it, in the given salt. Here, so what you do, you take a nichrome wire, and here is hydrochloric acid in it, concentrated hydrochloric acid. You just dip this nichrome, the hydrochloric acid, and then take a crystal or so of the sample, and then put it in the flame. And then you get the color of the flame. And most likely the metal ion, that lithium, sodium, potassium, shows a bright color. For lithium, it is bright red. For sodium, it is bright yellow. For potassium, it is radiant. That is the color of the potassium salt. But you go to metal ion, a group 2 metal ion, then beryllium, we don't see any color. Magnesium, we don't see any color. That means we don't see characteristic color which you can identify by eye, naked eye. But they do also have emission of color which you could not see in naked eye. Therefore, we'll say no color, but here we write bright red, pale green. We'll take the next slide. Now we are to talk about chemistry. That means how it reacts, what are the compounds it give us, and how the compound shows its properties, main properties. So group 1, group 2 elements are similar in chemical properties, almost similar, I would say, because this one has got valence electron always ns1. So their properties should be similar. Even though their properties should be similar, but there is a trend, and that trend we will discuss. Similarly, the beryllium to barium, the properties should be same according to valence electron. Similar, same if not similar, but there also there is a trend. We'll talk about this trend in the while we are talking reactions. So what happens if we react metal group 1 element with oxygen? We get a violent reaction, very violent reaction, and form metal oxide. An example, we take sodium solid and oxygen gas, and then we get sodium oxide solid. Similar for M prime, that means group 2 elements, we get metal here, metal in solid, oxygen gas, and then get metal oxides. Well, then you can see from this reaction, we can, if you remember our redox reaction, we can immediately say this one and this one is acting as a reducing agent. And this one is a very fast reaction, violent reaction. It's a moderately violent reaction. If we react with these elements with water, what happens? In general, it should give us metal hydroxide. Well, then you see here is a picture I show. This is sodium. We just dropped in water. It started being a ball of fire like this, and then so violent that with a ball of fire, and slowly this ball reduces in sizes and then vanishes. And the solution left is sodium hydroxide and hydrogen gas there coming up. And so this sodium hydroxide is an aqueous solution. We call it alkaline solution. When you write it, sodium hydroxide, AQ, it's alkaline solution of sodium hydroxide. And the pH of this, which identify the solution, whether it is acidic or alkaline, to look into it. pH 14 is the highest pH. That means it is alkaline. And if the pH go down, and then it becomes acidic, and one will be the pH 1 will be the highly acidic solution. Well, magnesium reacts, I would say that in water, cold water even, sodium violently reacts, but magnesium reacts extremely slow. And it's alkaline solution having low pH than that of sodium hydroxide. But in steam, if we heat magnesium in steam gas, we don't get magnesium hydroxide. We get magnesium oxide and hydrogen gas. This reaction is also violent. Well, you see, reaction with halogen we are talking about. We say this has got valence electron 1, S1. This is S2. So this M, valence electron S1, but if we take the valence electron of halogen, we'll see that there are 7 valence electrons. So M immediately give up its electron to this halogen, forming an octet here, and also a stable electronic configuration, thereby forming compounds. And this MX is all metals reacts with halogen give white solids. Similarly, all alkaline metals reacts with halogen gives white solid too. And these are ionic crystalline solids. I should discuss one more thing, why we call it alkaline metals and why we call it alkali metals. Because when we react this with water, we get alkaline solution. That's why it's alkali metal. Alkaline earth metal. Why do you say that alkaline earth metal? Because these elements are found in nature as compounds. And therefore, as they are occurring in nature in compound, therefore we call this alkaline earth crust. Earth crust to get the minerals of this compound, and therefore we call them alkaline earth metal. Okay, now we come to properties of these are the some compounds, main compounds we discuss about alkali metal and alkaline earth metal. But there are other compounds also, sulfate and nitrate, etc. We are not talking this, but we go to the properties of those metals or compounds. Hydroxide. What happens? I say it is a white solid soluble in water and forming alkaline solution. The solubility of hydroxide increases down the group. So this, if it's lithium hydroxide, sodium hydroxide more soluble than lithium hydroxide, and so forth. It is increasing. That's why you say we have to also take the trend of, though it should be similar type of compound, there are trend to be followed also. And if we take hydroxide, we said it's quite soluble in water and giving alkaline solution. Solubility is increasing down the group, and the hydroxide has strong bases. Actually, it's ionized in water, giving us cation and anion. If we take an example, if we dissolve sodium hydroxide, what we get? We get sodium ion and hydroxyl ion. But this is what is an hydroxyl ion. Okay. We take carbonate. These are unusual carbonates because we know that carbonates are other carbonates than that of group 1 and group 2. Carbonates are unsoluble. That means it doesn't dissolve in water. But these are unusual two. They dissolve in water. Solution of these carbonate becomes alkaline. Why? Carbonate ions removes hydrogen ions, forming a molecule hydrogen carbonate and hydroxide. The reaction here, carbonate ion dissolved in water, gets hydrogen carbonate ion and hydroxyl ion. Another unusual feature that group 1 carbonates do not decompose on heating. Exception is lithium carbonate. Lithium carbonate do decompose in heating. You might say why? Because this is because of the ionic charge of lithium ion. This is a very small ion compared to other sodium, potassium, rubidium, and cesium. Now we talk about nitrates of group 1 elements. Please note that MnO3 is the formula of nitrate, general formula of nitrate of group 1. You can see here that M is always having oxygen state 1. There are crystalline solids, soluble in water. Crystal of sodium and potassium nitrates are much harder to decompose. We cannot decompose very easily this other than metal nitrides. other metal nitrides. Okay, if we heat nitrite, metal nitride, we get metal nitrite, then not metal nitrate decomposes to metal nitrite and oxygen, except lithium. What happens lithium? If we hit lithium nitrate, we get lithium oxide, nitrogen dioxide, and oxygen like other metal nitrates. Well, one thing is this, potassium and sodium compounds can be used as chemical reagent. Why? Because three points is there. One, in solution, these potassium and sodium act as a spectator arms. That means they do not take part in reaction, but they are used as reagent. The potassium compound more soluble, and this is one of the reasons why we use this as a chemical reagent. And other hydroxides are less soluble and that are not available in aqueous media also. The alkali ions are the compounds of alkali ions and alkaline metal ions are generally colorless. But depending on the anion, they can show color. So here it is chromate ion, which is yellow. Therefore, potassium chromate is yellow in color. That please do remember that alkali metals and alkaline metals compounds are colorless, except in some few cases where anions are colored and therefore the total compound is colored. So this will be our today's lecture. Thank you very much for your patience here. Thank you. We'll continue this in the next lecture.